So today we will be discussing about propositions in discrete structures of mathematics. So first of all, we will see what is a propositions. So proposition is any declarative sentence which is either true or false. Suppose I say 2 plus 3 is equal to 5. This is a true statement. Suppose I say close the door. This is neither true nor a false statement. So this is not a proposition. And we will be dealing with all kind of propositions. Now, first we will see about negation. Not. Let P be a proposition and negation of P will be denoted by not P. Right. So suppose I write truth table of negation. So I will write like this: P, negation of P, true, false. Negation of P will be false for this and true for this. And then we will discuss about conjunction. In short, we call it AND. Suppose there are two propositions P and Q. Conjunction of P and Q will be denoted by this: P and Q. And when I will discuss the truth table, it will be like this: P, Q. The sample space of P can be either true or false, and I have P and Q. So sample space will be 2 to the power 2, 4. So I will make 4 rows, and here I will write P and Q. तो पहले यहाँ पर truth, false, and then alternative. It helps in covering all type of sentences. And when the conjunction says when both are true, then it is true. So for the rule is, if both are true, only then I can write here true. If any one is false, it will be a false. And next is disjunction. In short, हम बुलाते इसे और. If P and Q are two propositions, and I will write here, then it will be denoted by P or Q. For this, when any one is true, I can say it is true. So this will be, and then now let's have a practice question. I have to make a truth table for this P and Q or R. So I have three propositions P, Q and R, and one can be either true or false. So sample space will be 2 to the power 3, 8. So I will make 8 rows, 1, 2, 3, 4, 5, 6, 7, 8. P, Q, R. I will write T, 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 F, F, F. One more row I left. And then double T, double F. This helps us in covering all kind of statements, right? And then alternative, true and false. Alternative, true and false. And what I have to get? P and Q whole or R. So P and Q will be, and then P and Q whole or R will be. So this will be and. So any both should be true. If any one is false, I will write false simply. And this whole or with R. So any one should be true. Any one should be true. If both are false, then false. Any one should be true. So this is also the final answer. It is matching. right? Just a second. This and this is false. This both is false, so this will be also false. Now it is correct, right? And then we will discuss about exclusive OR, that is XOR denoted by this symbol, and it says when both are different, then I will get my proposition as true. So if there was XOR here, so if both propositions are different, I will get true. The XOR, this is the rule. So if both are different, I will get true. So this will be the final answer. And now seeing about conditional statement. So what is conditional statement? It is denoted by if P is a proposition and Q is a proposition, that it is denoted by P arrow Q, and it says if P is true, Q and Q is false, then the proposition will be false. It is like a promise which is only broken if you made it, and if you and then did not, you kept it. Suppose first I will write here for P arrow Q, right? This can be written as suppose, for example, this is true if P is true and Q is false, then it will be false, right? So this is false, this is true, and this is true, right? Now suppose you told me to keep umbrella with myself, okay, and you told me, suppose you are P, you told me to keep umbrella with myself, and I kept umbrella. So the promise is made. You told me to keep umbrella, but I did not. So this is a very bad condition. So this is false. You did not told me to keep umbrella, but I kept umbrella, so that if it will rain outside, it will help me. So this is also a beneficial condition. You told me to keep, you did not told me to keep umbrella, I did not took the umbrella. So no promise made, no promise broken. So this is also true. Now converse is simply Q arrow P. So this will be simply, what will now happen? P true, Q true, P true, then this is true. False but true, this will be also true. True but false, then it will be false. False, false, true, right? So TTFT, and right now we will be discussing biconditional statement, that is XNOR. Biconditional statement is denoted by P double arrow Q, I mean arrow having head in both directions, and it will give me true only if both are different. So it is just opposite of XOR, right? Now we will be dealing with a question. So I am removing this board, and then So I have a function P Q. I have to find P arrow Q. Right, conditional statement. Q arrow P converse and negation of P arrow negation of Q, and also I have to find negation of Q arrow negation of P. Right. So let's find one by one. T T F F. Let me adjust this one. I have to make 4 rows. Right. Right. So I will see. I will write here true, false, true, false. Now conditional statement true, true. So this will be true. True but false. So false, false but Q is true. So true, and then again true. Now true, true, true. False but it is true. So P is true. The promise is not broken. So this will be also true. Q is true but P is false. So this will be false and this will be true. Right. Now we will see the negation. So negation of P I will write here, and then when I will write negation of Q, right? So negation of P will be false, false, true, true, and negation of Q will be false, true, false, true, right? And then negation of P, arrow negation of Q, conditional statement will be for here it will be true, false but true, true, true but false, false, and then true and true, true, right? And simply negation of Q, arrow negation of P, that is conditional statement. Here it will be true, true but false, false, right? False but true, true, true and true, true, right? And this is the final answer: true, false, true, true, and true, true, false, true, right? This is correct. Similarly, I have to make truth table for this P or Q, arrow P and Q, right? So I will simply make truth table here, and P or Q, P and Q, and then this statement, right? This proposition. So simply I will first write. I will write here true, 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 true. I mean true, true, false, false, and then true, false, true, false. P, P or Q. So any one should be true, any one should be true, any one should be true. P and Q both should be true. And now first is true, second is also true, true. First is true but second is false, false. First is true, second is false, again false. Both are false, then true, right? And I have to find P or negation of Q having conditional statement with Q, right? So negation of Q will be written as false, true, false, true, and P or negation of Q will be written as P or negation of Q will be written as any one should be true. So true, true, false, true, right? And this P or negation of Q arrow with Q, this whole conditional statement can be written as this is true but this is false. So this will be false, both true, true, both false, true, and both true, so true. Right. So the final answer is this. True, false. Right. Okay, I have made this with negation of Q. I had to make this with Q. Yes, so it will be the opposite. I have made this thing. The solution of this is, if the question was this, then this should be the solution. Right. Now, we will be talking about logical equivalence. Right. So, notation, what is logical equivalence? Suppose I have two propositions P and Q. So, both are logically equivalent if they both propositions have same they both are logically equivalent if the columns of both propositions will be same. So P triple arrow with Q, right? P Q and suppose I got something and then I wrote a statement negation of P arrow Q and I got something. If these both columns are not same, then we cannot say that these two are logically equivalent. Right. Now we will talk about distribution law. So in algebra, distribution law simply means this, right? Breaking the both. Here it applies to or, over, and over, or. So this can be, this can be written as P or P and Q or R. It can be distributed as and, over, or. So P and Q or P and R, right? Similarly, P or Q and R can be written as P or Q and P or R, right? So let us see whether it is correct or not. So I am going to turn this over, right? So suppose I have P, Q, R, P and Q, P and R, Q and R, P or Q and P or R, right? And P or Q and R, right? So this will be true, 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 false, 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 true, true, false, false, true, false, false, true, false, true, false, false. This is or. So any one should be true. And this is also or. So any one should be true. right? And Q and R, so both should be true. P or Q and P or R, right? P or Q and P or R. P or Q, P or R, so both should be true. P or Q and R, so P or Q and R, so only one should be true. 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 Right, only one should be true. You can see, so these two are logically equivalent, right? Similarly, you can also prove for, right, you can also prove for this one. You can also prove for this one also, right? Now, what is De Morgan's law? So, De Morgan's law is negation of P or Q is equal to negation of P or, sorry, negation of P and negation of Q right? And negation of P and Q, negation of P or negation of Q. You can also verify this using truth table, right? And then absorption's law, right? So we will discuss what is absorption law. P or P and Q is equivalent to P. How? We will make truth table and see. If P already appears outside and entire compound expression collapse to just P, so this is absorption law. Here or absorbs and P or Q will also give P. Let's make the truth table. P, Q, right? Truth, true, false, false, true, right? P and Q, false, false, and P or P and Q, right? So any one should be true. This and this same. Also here P, Q, true, false, false, true, right? P or Q, any one should be true, and P and P, so both should be true, right? And tautology. What is tautology? A compound proposition always true no matter what truth values of propositional variables that occur in its tautology. So P or negation of P, that is negation of P, P or negation of P, so this is always true. I get both columns always true, and this is tautology, and I will get a contradiction if both will be false, so that will be P and negation of P, that is P, negation of P, true, false, false, true, P and negation of P both should be true. So this is false, this is false, this I got contradiction, right? This was all it is. We will see in next video.